You want to test the claim that the average height, I think this should be height, of men living in Rockland, California is less than 65 inches. You ask 17 men their height and record the results. If alpha is 0.005, find the critical value to 3 decimals. So the first thing I'll do is identify the claim. Well, the claim is that the average height is less than 65. So I'm going to say average, mean, is less than 65. Now the opposite of that claim is mu. The mean is greater than or equal to, I don't know why I'm writing 64. That should be 65. And so getting the null hypothesis, that's going to come from and be associated with the opposite. And I change that to equals. The alternative hypothesis then comes from the claim. And it's just exactly what the claim is. Or in general, it's whatever the symbol that doesn't have an equal sign in it is. That'll be our alternative hypothesis. And of course, the alternative hypothesis tells us what kind of test this is, left, right, or two-tail. And since this is less than, it's a left tail test. So that means my entire significance level goes in the left tail. And I need to find the t critical value that has 0.005 to the left. Now I have to keep in mind this is a left tail test. My significance level is 0.005 and my n, my sample size, is 17. So I'm going to do this two ways. I'll look up the critical value on our t distribution table, and I will also do the same thing using a spreadsheet. So knowing that this is a one-tail test, I can focus on the area in one tail. Now I was told my significance level is 0.005 and my n was 17, so that means my degrees of freedom, which is n minus 1, in this case is 17 minus 1, which is 16. So I'll find my critical value in the first column in the 16th row, and that'll be 2.921. The problem is this is a positive value, but over here on the left side of a bell curve, standard bell curve, you should have negative numbers because 0 is right in the middle. So all we have to do is realize that if we're talking about a left tail test, all these numbers, all these values on the t distribution table become negative. So I just throw a negative in there, and I've got my critical value for this test. Now, if I want to use a spreadsheet to find this, all I have to do is keep those same things in mind. The significance level, the degrees of freedom is 16, and the fact that it's a left tail test, and I should end up with a negative critical value. So I'm going to throw in to the t_in function the significance level and the degrees of freedom, and that tells me my critical value is negative 2.921 if I round to 3 decimal places. Exactly what we got. So one thing to point out is the t_in function gets the critical value, rather the t value that has this area to the left. So that has 0.005 to the left. If we wanted if we were conducting a right tail test, then I simply need to change this to a positive value.